And if you can, do this as closely as you can to what I have up here. We're talking about fractions and number lines. By the way, when we talk about fractions and number lines, where do you see fractions and number lines? Anybody? Fractions and number lines. Where do your parents, where do you see this on a daily basis, probably? Sometimes they're crooked number lines. Sometimes they take the number lines and they go like this. And they split those into these little things here. And it goes 0, 10, 20, 30, 40, 50, 60. And then sometimes there's a little arrow that goes here, points like that. Or, here's another example that I'll bet maybe will look familiar to you. Yeah, we got all these numbers. Exactly. A ruler is nothing more than a number line. And this one here is a speedometer on a car is a number line with cutting the fractions. So we use that kind of all the time. Your parents do. You will when you get to be 16 or 15 or whatever it is here. But looking at these right here, if I asked you to name the fraction, or just to name the point, name the points. Okay, if I asked you to name that point, point A, you would tell me it is? Brian Connor?
1.5 or 1.5.
Yeah, we're doing fractions, so it's 1.5. Okay. Now, if you are naming fractions on number lines, let's talk about the thought process we should use. What's the first thing when you're using a number line you should look at? And you're talking about the points. Okay. The first thing you need to look at is, okay, look at the whole numbers. In other words, the first thing Ryan should have looked at here was that his point A falls between what two big numbers? 1 and 2. Okay, so it's going to be 1 in some fraction. Just like here, when I look at this one, the first thing I start off is writing, well, that thing is 3 whole units, and then a fraction of the next one. Or this one here is 4 whole units, and then I have to put whatever fraction is left after that. Okay, so that's the first thing you want to look at. You just look at it and say, okay, I know the whole, it has 3 or 4 or 5 or all of these. Okay, the second thing is this. You need to figure out the scale, or how many pieces is each unit cut into? Okay. For example, this one here, between 1 and 2, how many equal spaces are there? There's 2, and that's where Ryan got his 2 on the bottom of his fraction, because this is 1/2 of the way to the next one. That's where the bottom number 2 came from. It's 1 out of the 2 spaces away. This one over here, okay, and again, I warn you, don't count the hash marks, Colin. Don't count the hash marks, because the hash marks will not get you the right answer. Because you'll count and go, oh, there's 1, 2, 3, 4, 5, 6. It's cutting it into 6 pieces. No. Count the spaces, because how many spaces are there between 3 and 4? 1, 2, 3, 4, 5. There's 5 spaces. It cuts it into 5 equal pieces. And how many pieces over is it? 1, 2, 3. So this point is 3 3/5. This point over here is 4 and how many fifths over? 1, 2, 3, 4, and 4 fifths over. Okay, so count the spaces, not the tick marks, because the tick marks will get you some sort of goofy thing. How about this one, even though I didn't draw it very well? What's the speed this car is driving here? Well, you know it's between, if you could read my numbers, it's between 50 and 60. Grace, it is,
55.
looks like 55. Oh, the old double nickels, as we call it there. Anybody ever call it double nickels?
No.
I didn't think so.
I know.
Let's see what else they asked us here. Well, here's a question they ask. Write down this problem. They said, Rob walked 3/4 of a mile. Rob walked 3/4 of a mile. Sam walked 2/3 of a mile. Who walked farther? Okay, now again, children, human nature in us wants us just to throw out an answer for Mr. Hahn, and maybe you're right, maybe you're wrong. But in math class, work and effort is worth so much. What do you suppose we're going to do? We're going to show which one walked farther. And since we're talking about number lines and stuff, we're going to do this. Here, we're going to draw 2 lines. And they are going to stand for, each of them, 1 mile. This first, Rob walked 3/4 of a mile, right? So how many equal pieces do I cut 0 and 1 into? What's the bottom number? 4. So I'm going to do as best I can to cut this into 4 equal pieces. How far did Rob walk? 3/4. So he went this far. Started here at 0, walked 1/4, 2/4, 3/4 of a mile. Here is Mr. Rob. Mr. Sam walked 2/3. Well, that's a little different because now I'm cutting my mile into how many pieces?
3.
3. That's a little tougher to do. 1, 2, 3. Do as best you can. He walked 2 of the 3 miles. Based on my best speculations there, who walked farther, Rob or Sam? Ocala? Rob did not walk farther. Oh, yes, he did. I was looking at Rob and Rob. Just forget I said that.
How do you know where to put your slash?
That's a great question. And that's where I said, when you're just sketching it out, Maggie, okay, the first thing you have to do is you start off with 2 as equal lines as you want. And then you say, well, the first one, I needed to cut it into 4 pieces. Okay, what's the easiest way to cut something into 4 pieces? Is to cut it in half, and then cut each half in half, because that gives you 4 pieces. And again, Maggie, there's no, I guess you could measure it and try to cut it in, but this is more about sketching and trying to do it relatively quickly. Cut it in half, cut each half in half, and now you've cut it into 4 pieces. With 2/3, you just got to try to do the best and say, okay, if I put my third in thirds, it is really just you kind of, as much as you can, guessing and getting it close to 1/3. Okay, there's no magic formula other than you could probably draw a line and cut it with rulers, but I don't want you to spend that much time on it. This is just about kind of sketching it out. Just like fifths, if I was going to cut a line into fifths, okay, you just kind of got to try to kind of guess. Here's 1, 2, 3, 4, 5. And if you don't like, if they don't look like they're really, if they're way off at the end or not even, do them again. Or if you end up with this one being too short, just make this line a little bit longer. You just want to try and get in the practice of doing it as close as possible. There's no magic. You know, I'm not going to make you draw perfect lines every time. But I should. Should I? Maybe I should.
No.
We could do that.
No.
You sure?
Yes.
How how about this? And again, if you were asked what's bigger, 1/2 or 3/4, what should you do? Don't just tell me which one is. And see, that comes tomorrow, so I don't know, maybe I shouldn't even go with that. But let's do it. We could actually do this, and I could just give you an extra lesson there. Caleb?
Sketch it out.
Well, and how would you go about doing that?
Maybe draw a square circle.
I would go with squares, because squares are a lot of times easier. If you like circles, that's fine, but the circles are okay if you're talking about 1/2s and 4ths, but circles get a little tough when you're talking about 5ths and 6ths. And this is actually tomorrow's lesson, so maybe I'll just give you tomorrow's assignment, we'll skip a lesson. Okay, if you want to compare 1/2 to 3/4, you draw yourself a box, and draw yourself a second box that is as close as humanly possible in size. Okay? Close as humanly possible. If you cut this in half, you have 1/2 of it. If you take this one and cut it into 4ths, again, the best way is to cut it in half and then cut each half in half. You have 3/4. Which one has more shaded? Madison? Now, can I go on record as telling you that this is a very kind of primitive way to do it, and you won't do this for really long, because, you know, if I gave you this problem, what if I gave you 7/8 compared to 21/50?
I don't want it.
Where's the problem come in there? Alex?
You can't divide, or you can't draw 50 squares.
Oh, I could.
Yeah.
It's not going to be very easy. Okay, so this is okay as long as you're talking about small fractions that have small numbers on the bottom, because that's okay to do. But when you start doing this, this only works for a little while, and then we start doing big ones. But let's do 7/8 compared to, and here's the other problem. What is bigger, 7/8 or 3/4? We're taking a guess here. Who knows for absolutely positively sure? Sammy?
7/8.
Are you 100% sure? How can you tell me for 100% sure? How can you tell me for 100% sure?
Because, if you cut it into 4 pieces, bigger pieces, and,
Yeah, but you would have 3 of them.
yeah.
Well, here, let me draw the picture. Let me draw a picture. Eight, cut half, now make 4s, cut each one of those. I have 7/8, which means I have 1, 2, 3, 4, 5, 6, 7. Cut it into 4ths. I have 1, 2, 3 of them. Which one do I have more shaded? Caleb?
7/8.
But isn't this bigger than that? Isn't there more of that there? Maggie?
Aren't they equal?
Aren't they equal? So if I gave you 7/8 of a dollar, that's the same as 3/4 of a dollar? Which one is actually bigger? 7/8 is bigger.
Yeah.
Okay, and I was just doing this to kind of fun with you a little bit. Okay, because when you do this, your boxes have to be the same size. I can't draw the world's largest box over here and then a little teeny tiny box and then try to compare them by shading. Okay, they have to be the same, and that's why this is only good. This is only good for so long in the 5th grade world, and then we go on to bigger things. Had I made this box, the 3/4 box, the same size, and cut it into 3/4, and I'm still a little big there. Cut it into 3/4. You can tell 7/8 is going to be a little bit bigger than that, but we'll talk more about that later. I don't want to confuse you any more than I already have. Madison,
What is this?
still fractions. Same fractions we've been doing.